Hello all, welcome to JSM Learn. Here in this session, we are going to discuss previous JEE questions of the chapter Motion in a Plane from the topic Motion in a Plane and Projectile Motion. Here comes the first question. The velocity of a particle is given by v is equals to minus x I cap plus 2y j cap minus z cap meter per second. The magnitude of acceleration at point 1 comma 2 comma 4 he is asking. So it is very easy to solve. Here are the given values. The x directional velocity, y directional velocity, z directional velocity we have taken separately. Now at this point we have to find magnitude of acceleration. So for that, acceleration is nothing but rate of change of velocity. So dv by dt, which can be written as d by dt of the given value minus x I cap plus 2y j cap minus z k cap. Now d by dt of minus x, it can be written as minus of dx by dt I cap plus 2 into dy by dt into j cap, and next minus dz by dt into k cap. So dx by dt is nothing but rate of change of displacement in x direction, here in y direction, here in z direction. So we can take it as minus vx, because rate of change of displacement is velocity. So minus vx I cap plus 2 into vy j cap minus vz k cap. So after that we have to substitute the values of x, y, z velocities in these directions. So minus of vx value is minus x I cap plus 2 into vy value is 2y into j cap minus vz value is minus z. So minus z into k cap. Now minus into minus plus, this equation can be written as acceleration vector is equals to x I cap plus 4y j cap and plus z k cap. So at what point he is asking the acceleration? 1 comma 2 comma 4. So at 1 comma 2 comma 4, this acceleration becomes a is equals to 1 I cap plus 4 into 2 j cap plus 4 k cap. Now this will become I plus 8j plus 4k. Now he is asking for the magnitude at this point. To find the magnitude, what is the formula, sir? A magnitude is equals to under root x square plus y square plus z square. So we can take here 1 square plus 8 square plus 4 square, which can be under root 1 plus 64 plus 16, which can be equal to root 81. So the answer for the magnitude of acceleration at point 1 comma 2 comma 4 is 9 meter per second square. So from the options, option B is correct. Here comes the next question. Two identical bodies projected with the same speed at two different angles cover the same horizontal range. So when we get same horizontal range for same speeds and identical bodies, when these two bodies are projected at complementary angles, it may be 30-60 or it may be any angle 37-53, like that, any complementary combination of angles. So the range is common. So R1 is equals to R2 is equals to R. Now if the time of flight of these bodies is t is equal T1 5 seconds, first body taken 5 seconds to complete its path, and T2 is 10 seconds to complete its path. Now he is asking then the value of R. Then the value of R he is asking. So R1 is equals to R2 is equals to R is there. So that value of range we have to find. So for that we have the formula of time of flight. T is equals to 2u sine theta by g for any projectile, and range formula R is equals to u square sine 2 theta by g. So by using these two relations, by using the given values, I am writing the equation as T1 is equals to 2u sine theta 1 by g, and T2 is equals to 2u sine theta 2 by g. If theta 1 plus theta 2 is equals to 90, this theta 2 value can be written as 90 minus theta 1, which can be sine 90 minus theta will be equal to cos theta. So 2u cos theta 1 by g we can write. So if we multiply T1 and T2, T1 into T2 will be equal to 2 into 2, 4. So I'm writing 2 here, and in the denominator here g. So first of all we'll write 2u sine theta by g into 2u cos theta by g. So this can be written as 2 into u square sine 2 theta by g, and another g I'm writing here. So this will be T1 into T2. So if you observe this equation, u square sine 2 theta by g is the equation of range of a projectile. Now take this value to the one side and remaining values to other side. So r is equals to 1 by 2 g T1 T2. When the angles are complementary, the projectile angles are complementary. So this r value he is asking, and what is the given value for T1 and T2? We can directly substitute here. So r is equals to, range of the projectile is equals to 1 by 2 into g value he given 10 meter per second square. So 10. Now T1 T2, T1 value is 5 seconds and T2 value is 10 seconds. Those 2 ones are 2 5s are, so 5 5s are 25. So range of the projectile is 250 meters. So from the options, option A is correct. And next, a gun mounted on the ground fires bullets in all directions with the same speed. So there is a gun, he's firing in all directions from the ground. At what angle he didn't given, but the farthest distance of the bullet could reach 6.4 meters. He may fire with any angle, but the longest distance is 6.4 meters. It's a very short range gun, I think. Now 6.4 meters is a long range means, so r value is 6.4 meters. For maximum distance to cover by any projectile, we take the angle theta is equals to 45 degrees. Because in the range formula, for the angle of theta is equals to 45 degrees only, we get maximum range. So he given it is the maximum distance, so we can take r is equals to 6.4 meters occurs only when theta is equals to 45. Now g value is given 10 meter per second square. So he's asking the speed of the bullets from the gun. So whenever the bullet leaves the gun, almost all the bullets will have the equal speed. So that speed he is asking, the speed of the bullets from the gun is he asking. So for that, I'm writing the formula of range. R is equals to, for a projectile, u square sine 2 theta by g. Here theta is equals to 45 because maximum distance. Now r is equals to, here u square sine 2 into theta, 2 into 45, it will become sine 90. So sine 90 value is 1. So u square by g into sine 90, or we can directly write r is equals to u square by g. So this is the maximum range. We have r value. So if we substitute here, 6.4 is equals to u square by g value given 10 meter per second square. So just substitute into this, u square is equals to 6.4 into 10. So this will be 64. So u square is equals to 64, then u is equals to, there is a possibility of minus 8 and plus 8. But in this case, the speed he is asking, so there is no particular direction. In all possible directions he is firing. So in this case, we have to take the magnitude. So u square is equals to 64 means u will be 8 meter per second. So here the answer is the speed of the bullets from the gun will be 8 meter per second. Now, if x and y coordinates of a projectile as a function of time are given at given as 24t and 43.6t minus 4.9t square respectively, then the angle in degrees made by the projectile with the horizon. First of all, we see the diagram. There is a projectile like this. So this is the starting point. It has x value depending upon the time and y value also depending upon the time. The entire equation given in the time. Now after 2 seconds of projection, it will reach at some point. It will reach some point. At that point, he is asking the direction. This angle he is asking. Let us consider it as alpha, because theta will be the angle of projection. So to find this alpha, we have these values from this triangle. If you consider this as a triangle, now this will be the velocity, final velocity after 2 seconds, and in horizontal direction this will be Vx, and this will be Vy. This is parallel to this, so we can take here Vy. So from this triangle we can write tan alpha is equals to opposite side by adjacent side. So Vy by Vx. To get alpha value, he is asking at 2 seconds. Initially the body is projected with some angle. After 2 seconds it is reaching some point. At that point he is asking the angle made by this projectile with the horizontal. This is horizontal direction and the projectile is going like this. After 2 seconds at this point, what is the angle he is asking. So for that, tan alpha is equals to Vy by Vx. From the given value, given that x is equals to 24t, so dx by dt, which is nothing but velocity in x direction, that is equals to d by dt of 24t. So derivative of 24t with respect to time will be Vx 24 meter per second. Now if you solve for y also, we get y is equals to 43.6t minus 4.9 t square. So Vy is equals to d by dt of 43.6 t minus 4.9 t square. Now if we derivate this, we get the value 43.6 minus 2 into 4.9 into t. So this will become 43.6 minus 9.8 t. So if you observe the velocities you got here, the Vx value is independent of time. Whenever the projectile is projected, the horizontal velocity remains constant. So initially it is having some velocity 24 meter per second. The same velocity remains in the x direction. But if you look at the y velocity, the y directional velocity 43.6 minus 9.8 into t. So if you substitute the time value here, you get a different values. So in this case, he is asking at t is equals to 2 seconds. So Vy at 2 seconds will be 43.6 minus 9.8 into 2. So this will become 43.6 minus 19.6. So vertical direction velocity becomes Vy 43.6 minus 19.6 means it is 24 meter per second. So if you look at the formula, tan alpha is equals to Vy by Vx. By using these two values, we can get tan alpha is equals to Vy by Vx. So Vy value is 24 meter per second and Vx value is also 24 meter per second, which is equals to 1. Now tan alpha, when we get tan values as 1, sir, so tan alpha is equals to tan 45. So the angle will be 45 degrees. So here comes the option B, which will be correct. So this is the way to solve the projectile motion questions. These are very easy and important for the JEE. So thank you for watching. Subscribe to our channel JSM Learn.